Welcome to this explainer. Okay, today we are diving headfirst into a really fascinating chapter on water resources. It's a topic that might seem simple on the surface, but it gets incredibly complex when you actually dig into the data. We're going to break down exactly why a resource that literally falls from the sky is somehow becoming our most critical global shortage.
Think about it. We all learned in grade school that the water cycle makes water a renewable resource, right? It's always moving, always recharging. So how on earth can we run out? Why do the projections show that nearly 2 billion people will be facing absolute water scarcity by the year 2025? That's the paradox we really need to unravel today.
So, here's our roadmap for this explainer. First, we'll look at the scarcity paradox. Then, what actually causes water scarcity? Followed by a look at dams. Were they really the temples of India? Then the downside of those mega dams. And finally, we'll wrap up with some really cool rainwater harvesting solutions.
All right, let's jump right into part one, the scarcity paradox, and how a blue planet is somehow running dry. When you hear the phrase water shortage, you probably picture a vast, dry desert, right? Maybe people walking miles for a single pot of water. That is what we call quantitative scarcity, literally a physical lack of water. But there's another kind that's just as dangerous, qualitative scarcity. You could literally be surrounded by water, but if it's too polluted to drink, you're still in a drought. Take Kolkata, for example. The source text highlights a time they got hit with 180 millimeters of overnight rain, massive flooding everywhere. Yet, ironically, people were scrambling just to find safe drinking water. Water everywhere, but not a drop to drink.
Moving on to Section 2, what actually causes water scarcity? Let's look at the modern culprits.
So who or what is actually to blame? Well, it's modern lifestyle choices and unchecked urbanization. It's not just that it's raining less, it's the sheer immense pressure we're putting on the system. Our population is booming, meaning we need way more water to drink, and crucially, way more water to grow food. To pull that off, farmers often have to overexploit groundwater for irrigation, just driving those water tables lower and lower. Then, throw heavy industry into the mix. Multinational corporations guzzle water and need massive amounts of hydroelectric power. And urbanization? If you look at modern housing societies, you'll often find independent groundwater pumps in every single complex. Everyone is individually tapping into the exact same fragile aquifer, draining it right beneath our feet.
Okay, Section 3, Dams, Temples of India. Let's talk about how we attempted a mega solution.
If you look at the sheer geography of it, the scale of river damming across India in modern times is just staggering. From Bakra Nangal up north to Nagarjuna Sagar down south, human intervention has touched almost every major river basin. We didn't just put up a few small barriers. We built massive, multi-purpose river projects to literally corral and control nature on a continental scale.
And these weren't just standard infrastructure projects. Right after independence, they were symbols of immense national pride. Jawaharlal Nehru optimistically called them the temples of modern India. The logic actually made a lot of sense at the time. These multi-purpose projects were supposed to integrate agricultural development with rapid industrial and urban growth. They were basically viewed as a silver bullet for a developing nation, delivering irrigation, electricity, flood control, and drinking water in one giant package.
But that brings us to Section 4, the downside of megadams and what happens when our solutions actually create new problems.
This is where we hit the dam dilemma. On one side, you have those intended benefits we just talked about: power, irrigation, water supply. But on the flip side, some really harsh, unintended realities have cropped up. It is incredibly ironic that projects designed to control floods actually ended up triggering them. How? Well, damming a river causes a ton of sediment to build up at the bottom of the reservoir. So when extreme rainfall hits, the reservoir just can't hold the extra water, leading to devastating induced floods. Plus, these mega projects have sparked intense interstate water disputes. A classic example is the Krishna-Godavari dispute, where downstream states like Karnataka and Andhra Pradesh really suffered because upstream Maharashtra diverted water for its own projects. One region's solution literally became another's crisis.
And ecologically, it's a devastating domino effect. When you mess with a river's natural flow, you severely degrade aquatic habitats. The dams fragment the rivers, making it super difficult for fish to migrate or spawn. Floodplains get deprived of natural silt, which is a crucial natural fertilizer, so the land degrades. Even the irrigation has a dark side. It encourages farmers to switch to commercial, water-hungry crops, causing severe soil salinization. There have even been observations of these projects inducing earthquakes and spreading waterborne diseases.
So those modern temples turned out to be incredibly expensive for the ecosystem.
Let's pivot to Section 5, Rainwater Harvesting Solutions, and a much more sustainable path forward.
If we want to see the real power of local solutions, we have to talk about the Shillong paradox. This is such a fascinating geographic anomaly. Shillong, the capital of Meghalaya, is located just 55 kilometers away from Mawsynram and Cherrapunji, which are literally the wettest places on planet Earth. You'd think Shillong would be absolutely drowning in fresh water, right? But no, the city actually faces an acute water shortage. It just goes to show that being geographically close to rain does not automatically guarantee usable water security.
So how do folks in Shillong handle this paradox? Well, to deal with the persistent shortage, almost every single household has adapted by using rooftop rainwater harvesting. It's a massive community-wide effort, and honestly, it works. This hyperlocal strategy covers up to 25%, a full quarter of the city's household water needs. Instead of waiting on a massive distant dam, they just capture the resource exactly where it falls.
Which brings us to our broader conservation goals, basically blending the old with the new. Step 1 is exactly what they do in Shillong. Capture water locally via rooftops and traditional structures. Step 2 is utilizing brilliant traditional micro-irrigation. For example, in Meghalaya, they have this 200-year-old system using bamboo pipes to tap stream water, delivering it drop by drop right to the plant's roots, which completely minimizes waste. And step 3 is pairing that local ingenuity with modern infrastructure, like the government's Jal Jeevan mission, which aims to guarantee 55 liters of piped water per person per day in rural homes. Combining that ancient ecological wisdom with modern infrastructure really is the key to rural prosperity and long-term ecological balance.
So we've seen how the grand engineering dreams of the past century brought almost as many problems as solutions. The real power? It lies in local adaptation and smart, sustainable use. So I want to leave you with a final provocative thought. From your own everyday experiences, how can you conserve water in your life? What small step can you take today to help prevent this looming ecological crisis? Think about it and let it change the way you interact with every single drop. Thanks for joining me on This Explainer.